On November 15th, astronomers made a shocking announcement about the true size of ThreeI Atlast. Data from James Webb show that this is not a small comet, a few kilometers across, but a gigantic mass, hundreds of kilometers wide, nearly equivalent to the core of a dwarf planet. Its surface clearly bears geological traces of having been heated and cooled many times, even having once hosted liquid water, together with jets rich in pH and nitriles. Exactly the prebiotic flavour, like a ship scattering chemical seeds across the galaxy. Surrounding Atlast are at least 6 satellites between 10 and 30 meters in size, flying in a stable formation, clearly showing signs of active control. The world faces 2 equally shocking possibilities. Either Atlast is a natural planetary core but is revealing a kind of physics we cannot yet comprehend, or it is a ship chaos structure, designed by a civilization that sees human technology as nothing more than stone tools. The United Nations is forced to go public Atlast is evidence of non-human technology. Humanity has no way at all to control or deter it, and from now on, Earth's history must be written in the context of knowing for certain that things like Atlast already exist and are travelling freely among the stars. In just one night, ThreeI Atlast was upgraded from a wandering fragment to the largest interstellar planetary fossil ever observed passing through the solar system. There are still many mysteries hidden inside ThreeI Atlast, and right after this we will explore together the latest research by scientists on the true size and structure of this object. At 11:47:23 p.m, UTC, the monitors watching ThreeI Atlast barely flickered as the numbers began to climb. For a few quiet seconds, the change looked like ordinary noise, a soft shimmer in the background around Atlast. Then the infrared channel surged and ThreeI Atlast brightened by a factor of 12 in just 90 seconds. The increase did not come as a spike and fade, but as a smooth, controlled rise that held steady around Atlast. In the control room, Sarah Martinez froze, watching the thermal curve of ThreeI Atlast bend upward like a lifted eyebrow. Her first instinct was to suspect a calibration error, a dead sensor or a software glitch injecting ghosts into Atlast's data. Checks went out across the network and other telescopes confirmed the same silent flare from ThreeI Atlast. Redundant pipelines, backup detectors and raw frames all agreed that the heat was real, coming directly from Atlast. For 14 uninterrupted minutes, the effective surface temperature of ThreeI Atlast hovered near 1200 Kelvin. No random venting or chaotic outgassing appeared in the spectrum, only a broad, stable thermal signature wrapped around Atlast. Every known natural model predicted that a body like ThreeI Atlast should respond with messy, sputtering plumes and drifting jets. Instead, the energy release from Atlast looked continuous, sustained and oddly disciplined as if tuned to an invisible dial. Sarah Martinez leaned back and realized that ThreeI Atlast had just violated the comfortable expectations of comet physics. The event was not merely bright, the event was orderly, and order on that scale demanded a new kind of attention to Atlast. As the thermal curve finally relaxed, the data log timestamped the end of ThreeI Atlast's first impossible heat pulse. What no one yet knew was that this calm, controlled burn from Atlast was only the opening move in a larger pattern. When the thermal pulse from ThreeI Atlast finally declined, the tracking software began to redraw the orbit in silence. For a few minutes, nothing seemed wrong until the velocity line for Atlast crept away from the prediction and refused to come back. Numerical fits showed that ThreeI Atlast had gained an extra 4.3 kilometers per second along its path. The change did not arrive as a gradual drift, but as a clean offset that snapped the whole future trajectory of Atlast into a new curve. To push a body the size of ThreeI Atlast by that amount, dynamicists calculated a required energy of about 3 × 10 to the 20th joules. On paper, the figure meant 70,000 times the yield of the largest nuclear device humanity had ever detonated, compressed into a 14-minute shove on Atlast. Modelers tried to blame chemistry, asking whether ThreeI Atlast could simply be venting enormous plumes of gas and dust. Every attempt to make outgassing do the work for Atlast demanded physically absurd mass loss rates and invisible jets that never appeared in the data. In all the simulations, a natural comet would stagger and wobble as random pockets of ice exploded away from the surface of ThreeI Atlast. Instead, the reconstructed motion of Atlast looked like a single coherent push, aligned neatly with the new trajectory. The more the teams tweaked parameters, the more stubborn the numbers around ThreeI Atlast became. Chemical energy sources, phase changes, and solar heating all fell short, by orders of magnitude in giving Atlast the recorded momentum change. In the end, the spreadsheets left 3I Atlast standing alone as a problem of pure dynamics. Whatever had acted on Atlast during those 14 minutes behaved less like a natural vent and more like a deliberate engine, and that implication lingered over every discussion that followed. Robert Chen stared at the residuals and realized that mathematics had already ruled out every comfortable explanation for 3I Atlast. The momentum change was fixed, the duration of the burn was fixed, and Atlast sat in the middle of those numbers like a quiet accusation. Chen began with the most generous model of ion propulsion humanity had ever conceived and scaled it up around 3I Atlast. He imagined engines stretching across valleys on Atlast's surface, thrusters pushing together along the new trajectory. Even then, the power curve refused to cooperate with 3I Atlast. To sustain such a thrust, the equations demanded an energy supply, like a large nuclear power plant running for decades, compressed into the short pulse already logged for Atlast. Chen replaced ion drives with fusion concepts around 3I Atlast and tried again. He stacked speculative reactors, exotic propellants, and high-efficiency nozzles, anything that a bold engineer might sketch while dreaming about Atlast. Each time the simulation finished, the same pattern surrounded 3I Atlast. The fuel mass grew absurd, the waste heat overwhelmed any radiators, and the machinery swelled until the hardware dwarfed the cometary body Atlast was supposed to ride on. The model no longer looked like an advanced version of human technology wrapped around 3I Atlast. The more faithfully Chen imported human ideas into the code, the more clearly the code rejected those ideas for Atlast. Chen finally wrote a single line in the margin of his report on 3I Atlast. Whatever propulsion system operated there ran on principles that made humanity's most advanced spacecraft resemble stone tools, and any honest analysis had to treat Atlast as evidence of a different engineering tradition. With that sentence, the conversation about 3I Atlast shifted. Teams reading his report no longer asked how to copy Atlast with present hardware. They asked what kind of mind would invest in such a vessel. When the heat pulse from 3I Atlast ended, the tracking systems kept quietly updating the orbital solution. For a short while, the fresh point still clung to the old prediction, as if Atlast were willing to pretend nothing had changed. Then the fit began to slip. The new positions of 3I Atlast pulled the curve downward, bending the path a little closer to the inner solar system with every update. Analysts reran the least squares solutions and watched the numbers around Atlast settle into a new orbit. The velocity vector of 3I Atlast now pointed more sharply sunward, angling toward the region where the terrestrial planets circle in their narrow lanes. When the final fit converged, 3I Atlast no longer brushed the outskirts of the system and moved on. The revised trajectory of Atlast cut toward the orbital radius of Earth with unnerving precision. Distance estimates tightened, and the future closest approach of 3I Atlast collapsed from a comfortable margin to roughly 0.04 astronomical units. On a human scale, that meant Atlast would pass at a few million kilometers, a deep interior flyby in gravitational terms. The calendar also shifted under the influence of 3I Atlast. The date of closest approach jumped forward, dragging the encounter from a vague window into a specific day, the 28th of December, 2025, as if Atlast had chosen to arrive early. Dynamics teams checked for hidden perturbations that might have nudged 3I Atlast, searching for missed mass concentrations or numerical mistakes. Every time the calculations were cleaned and redone, the solution returned to the same unsettling geometry, with Atlast steering closer and sooner. No impact was forecast, but the pattern was hard to ignore around 3I Atlast. A distant interstellar visitor that once seemed destined to skim past the sun now behaved like a craft adjusting course toward the inner planets, and that quiet change in the path of Atlast pushed the discussion from what happened to why here and why now. For years, the radio arrays had listened to 3I Atlast as a dull, steady whisper in the cosmic background. The receivers logged the usual hiss of the solar wind, the faint noise of distant quasars, and the soft, featureless murmur around Atlast. During the 14 minutes of the thermal event, that murmur changed. Across several frequency bands, 3I Atlast began to lace the noise with narrow, bright threads of signal, as if Atlast were clearing its throat on the spectrum. Data from widely separated antennas agreed that the source was fixed on 3I Atlast. There was no drifting interference, no passing satellite, only a stable point in the sky, where Atlast rode its new orbit. At first glance, the emission around 3I Atlast looked like a set of carrier waves, lined up in neat steps across the dial. When analysts at the SETI Institute zoomed in, they saw that the carriers around Atlast were not smooth. They shimmered with regular pulses and changes in amplitude. Jennifer Williams watched a waterfall plot of ThreeI Atlast stream down her screen in quiet disbelief. Within the bands tied to Atlast, she traced repeating patterns of bright and dark on and off, as though Atlast was speaking in a clipped mechanical rhythm. Natural radio sources tend to sprawl and wander, but the structures linked to ThreeI Atlast held tight frequency locks and clean edges. Noise usually smears information. The emission around Atlast seemed to resist that smearing, maintaining coherence far longer than any storm or flare. Statistical tests peeled away random fluctuations and left behind a skeleton of order centered on ThreeI Atlast. Periodicity modulation, depth, and symbol-like groupings all converged on the same conclusion: the signal environment around Atlast was carrying information, not just energy. Williams drafted her report and for the first time used a word that had stayed mostly theoretical in her field. She described ThreeI Atlast as a live techno-signature, a current example of technology in operation rather than a relic fossilized in ruins. To call ThreeI Atlast a techno-signature was to admit that some engineered system was active there and now. The moment that label settled over Atlast, the community shifted from wondering whether anyone was out there to wondering what kind of conversation Atlast had just opened. While teams passed the radio channels, other instruments were already turning to the light and high-energy photons around ThreeI Atlast. The same window that carried the voice of Atlast would soon reveal the sharp flashes and particle traces that hinted at an even more complex machine. The first hints came from telescopes that were not listening to radio at all, but watching the visible light around ThreeI Atlast. During the same 14-minute window when the orbit changed, photometers saw ThreeI Atlast sprinkle its reflected sunlight with sharp, needle-thin flashes. On raw-like curves, those flashes from ThreeI Atlast looked like teeth, rising cleanly above the background and dropping back to silence. Time tagging showed that the pulses from Atlast arrived with spacing controlled to better than a microsecond, as though a metronome were ticking somewhere deep inside Atlast. Amanda Peterson overlaid template patterns for known natural phenomena onto the data from ThreeI Atlast. Solar flares, lightning in giant planets, and comet outbursts all failed to match the regular clock-like spacing tied to Atlast. Peterson shifted to engineering analogies and asked what kind of device could imprint such structure on the light of ThreeI Atlast. The answer that kept returning was a high-power optical system, a laser-class source that could flicker on and off with extreme precision aboard Atlast. In her notes, Peterson described ThreeI Atlast as hosting a beacon, or link, a system capable of tight, power-efficient optical signaling. Whether the laser around Atlast served for communication ranging or something stranger, the behavior was indistinguishable from deliberate modulation. While the optical teams worked high-energy instruments turned to the X-ray spectrum of ThreeI Atlast. Instead of a soft blended glow, the detectors recorded sharp, narrow features that lined up like fingerprints of particles being slammed into matter near Atlast. Natural shocks can produce X-rays, but the lines tied to ThreeI Atlast were too clean and too stable in energy. They looked like the controlled output of beams being steered and brought to rest, as if an invisible accelerator were buried in the geometry of Atlast. David Hammond mapped laboratory accelerator signatures onto the spectrum of ThreeI Atlast and found uncomfortable agreement. The pattern around Atlast resembled high-energy particles, whipped into tight streams, then allowed to collide and radiate in a managed way. Hammond's summary treated ThreeI Atlast as the site of an integrated system, where lasers and particle beams might share a common power source. In that view, Atlast was not only speaking and steering, but also running a complex energy architecture, one that could drive propulsion, support massive computation, or in the darkest scenarios act as a weapon waiting in deep space. The radio signatures around ThreeI Atlast kept streaming long after the thermal pulse faded from the plots. For hours, arrays on different continents watched Atlast as a quiet set of carriers sliding through the background. Only when one long continuous stare was stacked together did a deeper pattern emerge around Atlast. An intern in the analysis group noticed that the brightest feature tied to ThreeI Atlast blinked in a repeating rhythm. He measured the gap between the strongest peaks from Atlast and found the same interval again and again at roughly 427 seconds. That timing mark became the first foothold in the language of ThreeI Atlast. Every 7 minutes, a structured burst rode on a carrier near 1.4242 GHz. Around that tone, Atlast hung a sequence of pulses like beads on a string. When the team unfolded the pattern from ThreeI Atlast onto a line, blocks of signal, and quiet fell into a clear progression. The lengths of those blocks from Atlast mapped onto the counting numbers, and then onto the prime numbers that cannot be neatly divided. 3. Atlast was not just counting 1, 2, 3 in the dark. The first long train matched 2, 3, 5, 7, 11, 13, a ladder of indivisible values. After the prime ladder at last began to weave in simple ratios, squares and cubes, and other relations of arithmetic. The longer they listened, the more ThreeI Atlast behaved like a patient teacher. Hidden beneath noise, Atlast repeated the same scaffolding, as if making sure that any mind on the other end could verify the steps. Natural sources can flicker and repeat, but they do not walk through the structure of number theory the way ThreeI Atlast was doing. Random plasma does not pause to underline the primes, or linger on perfect squares as carefully as Atlast kept doing. In the nightly briefings, the talk shifted from whether ThreeI Atlast was sending information to what level of mathematics Atlast expected a listener to understand. That question marked the passage from seeing Atlast as a strange object to seeing Atlast as a possible author of a universal textbook. Sarah Chen first approached the stream from ThreeI Atlast the way she would approach a new textbook. She laid out the sequences Atlast kept repeating, and marked every pause, every block, every return to primes. The more she stared, the less ThreeI Atlast looked like a random broadcaster, and the more Atlast looked like a careful instructor. The opening sections from Atlast were not about stars, planets, or maps. They were about how to talk in the first place. Chen flipped through earlier SETI literature and found an old word that fit what ThreeI Atlast appeared to be doing. In her notes, she wrote that Atlast was sending a primaire a foundational lesson meant to bootstrap a shared symbolic language. A primer starts at the lowest rung, and that is exactly where ThreeI Atlast began. Atlast emphasized primes' basic ratios and simple progressions, as if checking that any recipient could count, compare, and recognize structure. From there, the signal from ThreeI Atlast moved into more elaborate constructions. Atlast layered timing relationships, geometric hints, and repeated signatures that could be interpreted as this means number, this means distance, this means direction. Chen noticed that ThreeI Atlast kept circling back to earlier patterns. After each escalation in complexity, Atlast would reinsert the basic prime ladder, like a teacher reviewing old material before introducing the next concept. Natural turbulence does not rehearse its own building blocks, the way ThreeI Atlast rehearsed those blocks. Storms do not pause to make sure the student is still following, but the cadence of Atlast felt exactly like that kind of patience. In internal meetings, Chen argued that ThreeI Atlast was not just announcing existence. Atlast was offering the keys to decode whatever came next, embedding the grammar of the message inside the message itself. That interpretation changed how teams handled the stream from ThreeI Atlast. Instead of treating each burst from Atlast as a standalone puzzle, they began mapping correspondences asking which symbols might be equals, which might be object, which might be location. Once the word primer settled over the work, the expectations around ThreeI Atlast shifted again. If Atlast was spending this much effort to ensure mutual understanding, then whatever followed the primer would not be casual noise, and no one wanted to be the first to misread what Atlast was trying to say next. When the teams overlaid later segments of the stream, they saw that ThreeI Atlast was no longer only talking about numbers. The cadence that began as a primer from Atlast had started to grow muscles, filling out into something that looked more like a description than a lesson. By aligning timing markers, analysts realized that ThreeI Atlast was now tying symbols to directions on the sky. Patterns in the signal from Atlast repeated with shifts that matched known reference points, as though Atlast were pointing back toward a home star and forward along the current path. In one block, the spacing of tones from ThreeI Atlast mirrored the orbital radius of Atlast around the Sun, scaled through the units defined earlier in the primer. In another block, the velocity of ThreeI Atlast relative to the local standard of rest seemed to be encoded as a ratio folded into the same symbolic scheme Atlast had already established. What had begun as abstract arithmetic from ThreeI Atlast was turning into coordinates, ephemerides, and kinematic facts. The signal made ThreeI Atlast feel less like a mysterious comet and more like a vessel handing over its flight plan. But embedded inside those structured segments from ThreeI Atlast were stretches of binary that refused to line up with simple physical quantities. Run-length statistics on those sections tied to Atlast looked closer to compressed text or data tables than to clean mathematical exercises. Random sequences do not show that kind of uneven redundancy, and yet the blocks linked to ThreeI Atlast were too organized to pass as pure noise. Some windows from Atlast hinted at nested patterns, as if Atlast was stacking symbols to build larger semantic units. In private notes, several groups began to speak of ThreeI Atlast as a possible archive, The idea was that Atlast might be carrying a database, a set of records or instructions that only became accessible once the primer had been mastered. That possibility changed the emotional weight of every new bit coming from ThreeI Atlast. If ThreeI Atlast was transmitting more than a greeting, if Atlast was handing over a fragment of its own knowledge, then the task was no longer just to listen, but to decide how deeply humanity was prepared to understand what Atlast chose to share. The announcement that ThreeI Atlast had changed course spread quietly through mission control rooms across the world. Within days, Atlast was a recurring name on internal slides at space agencies that normally spoke in acronyms. At the European Space Agency, planners pulled old proposals from their archives and began sketching a fast intercept to ThreeI Atlast. The outline called for a compact spacecraft stripped of non-essential mass, riding a powerful launcher toward Atlast on a direct 8-month trajectory. If the launch window held, that European probe would swing to within about 1,000 kilometers of ThreeI Atlast. From that distance, cameras and spectrometers could watch Atlast in exquisite detail, and if conditions allowed, deploy a small sampler. The risk was obvious on every chart that mentioned ThreeI Atlast. No one knew how Atlast would respond to a visitor, or whether approaching too closely would trigger another controlled maneuver. In Beijing, a separate team walked through a different architecture, aimed at the same destination, ThreeI Atlast. Chinese engineers considered using heavy lift capability and electric propulsion to send a larger, slower craft into a rendezvous corridor around Atlast. That design traded speed for endurance, imagining long months of station keeping near ThreeI Atlast. The idea of orbiting Atlast even loosely felt like hovering beside an awakened animal whose moods were still unknown. At JAXA, conversations about ThreeI Atlast drifted into more radical territory. Some mission concepts dared to place human crews on a deep space vehicle, turning Atlast into the target of the first crewed interstellar encounter. The numbers surrounding ThreeI Atlast pushed back hard. Life support margins, radiation exposure and return trajectories all piled uncertainty on top of the already unpredictable behaviour of Atlast. Behind closed doors, the agencies acknowledged the same pull. Atlast was close enough, bright enough and strange enough that not going felt like a kind of failure, yet reaching out toward Atlast meant stepping into a situation no flight rule had ever anticipated. The first hint that ThreeI Atlast was not travelling alone came from a backyard telescope. On a clear night, Michael Stevens stacked long exposure frames of the star field where Atlast was creeping forward. The bright smear of ThreeI Atlast lay where the ephemeris said it should be. When Stevens stretched the contrast around Atlast, faint pinpricks of light appeared nearby, too steady to be noise. On the next night, Stevens returned to the same coordinates and repeated the sequence on ThreeI Atlast. The same tiny points showed up again, holding the same geometric arrangement around Atlast, shifted only by the motion of the whole group. Professional arrays were soon directed to the patch of sky containing ThreeI Atlast. Higher resolution instruments resolved at least 6 distinct companions, each perhaps 10 to 30 meters across, gliding in loose formation with Atlast. Tracking solutions showed that the companions did not tumble randomly around ThreeI Atlast. The smaller bodies maintained nearly fixed distances and angles relative to Atlast, like slow-moving vertices of a shifting but deliberate pattern. Natural fragments should wander, drift and collide as they fall in and out of weak gravity wells around ThreeI Atlast. Instead, the ensemble near Atlast behaved as though invisible thrusters were constantly trimming their paths. Dynamical models tried to treat the companions as debris clouds, loosely bound to ThreeI Atlast. Every simulation that removed active control saw the configurations smear out and dissolve, but the real data kept showing a crisp, disciplined arrangement around Atlast. Teams began to redraw their diagrams, no longer labelling ThreeI Atlast as a single object. The new charts described Atlast as the central element of a distributed system, with multiple nodes co-orbiting in a carefully managed frame. In hushed discussions, engineers compared ThreeI Atlast to a flagship moving with escort craft. Whatever language people used, the conclusion was the same. Atlast was not just a wandering relic, but the heart of an organised structure, whose pieces moved together with purpose. Speculation about the companions of ThreeI Atlast began almost as soon as the formation was confirmed. Around every table, people asked what kind of task would justify sending a small fleet to travel with Atlast. One school of thought saw ThreeI Atlast as the centre of an enormous sensor array. In that picture, the smaller craft around Atlast carried instruments and antennas, sampling magnetic fields, particles and radiation from multiple vantage points. With several platforms, ThreeI Atlast could triangulate disturbances in exquisite detail. The spacing of the companions around Atlast looked suspiciously like a baseline designed for interferometry, rather than a random spray of rocks. Others imagined ThreeI Atlast moving through space with its own shield. In that version, the objects near Atlast served as layers of armor sacrificial buffers that would intercept hazards before they reached Atlast. If ThreeI Atlast expected to pass through debris or hostile environments, throwing off smaller hardened shells made a certain kind of sense. The controlled spacing around Atlast could then be interpreted as optimized coverage or protective geometry, instead of a purely scientific one. A third group framed ThreeI Atlast as an operations hub. The companions became service drones, relay stations, or propulsion modules that could detach and reattach as Atlast adjusted its mission. In that scenario, ThreeI Atlast was less a single craft and more a modular architecture. Tasks could be distributed, failures isolated, and upgrades deployed without ever abandoning the main body of Atlast. None of these pictures could be proven, but all of them agreed on one point about ThreeI Atlast. The pattern in which the companions moved implied coordination, and coordination implied that Atlast and its attendants were following some shared set of rules. Seen through that lens, ThreeI Atlast was no longer just a curious interstellar object. Atlast was the visible core of a multi-component system, a structure whose purpose remained unknown but whose organization was impossible to mistake. When the first detailed images from the James Webb Space Telescope came in, ThreeI Atlast finally stepped out of the realm of guesswork. For months, Atlast had been treated as another small wanderer, something roughly in the class of Oumuamua or a modest cometary core slipping between the stars. The infrared maps told a different story about ThreeI Atlast. Instead of a tiny shard Atlast spread across the detector, as a sprawling complex body, its thermal glow refusing to match any compact model. Bright and dark regions on Atlast were separated by distances that could not be reconciled with the idea of a few kilometre fragment. As teams folded brightness and phase angle data together, the effective size of ThreeI Atlast grew with every iteration. The best fits placed Atlast in the range of hundreds of kilometres across, more akin to the core of a dwarf planet than to debris ejected from a casual collision. In quiet memos, astronomers wrote that ThreeI Atlast was now the largest interstellar object ever recorded passing through the solar system. Whatever else Atlast might be, it was not small, and that single fact began to reshape every theory built on the earlier, more comforting image of a harmless chip of ice. The moment the new size estimate settled, the nature of ThreeI Atlast had to be reconsidered from scratch. A body hundreds of kilometres across could not be dismissed as a casual chunk. Atlast demanded a planetary-scale origin. Spectra from the James Webb Space Telescope showed that ThreeI Atlast carried minerals and ices processed far beyond simple comet chemistry. The thermal inertia and brightness pattern of Atlast matched something, with depth layering and a long internal history. Planetary scientists began to speak of cores and mantles when they talked about ThreeI Atlast. In their models, Atlast looked less like a loose rubble pile, and more like the stripped heart of a once-rounded world. To fling such a massive object into interstellar space, the home system of ThreeI Atlast would have needed violence on a stellar scale. Simulations of tidal encounters and close passages in a crowded system showed how a dwarf planet could be torn apart, leaving Atlast as a surviving core. In that picture, ThreeI Atlast became a relic of catastrophe rather than a simple visitor. The broken world behind Atlast might never be known, but the idea that Atlast was the exposed nucleus of a lost dwarf planet quickly became the working hypothesis for anyone trying to understand where this interstellar shard of geology had come from. Laboratory teams turned from images to spectra, peeling back the light ThreeI Atlast reflected and emitted. Across the infrared bands, Atlast displayed absorption features that refused to line up with the clean profile of frozen, untouched ice. High-resolution fits revealed ammonia hydrates clinging to the surface of ThreeI Atlast. Those compounds, mixed with complex carbon-bearing materials, suggested that Atlast had once sat in an environment rich in chemistry, not just raw primordial frost. In the mid-infrared, ThreeI Atlast showed hints of rearranged crystal structures. The patterns implied that the ices on Atlast had been repeatedly heated and cooled, driven through cycles that erased the simple textures of a newborn comet. Geophysicists sketched cross-sections of ThreeI Atlast with internal heat sources. They imagined radioactive decay, tidal kneading, or both working inside Atlast long enough to melt and refreeze layers, to concentrate certain minerals and push others aside. Under those conditions, ThreeI Atlast could have hosted subsurface reservoirs pockets, where liquids once moved through fractures. The chemistry riding on the face of Atlas looked like residue left behind when those hidden environments finally froze and shattered. By comparison, untouched comets in the outer solar system looked crude. Their spectra lacked the processed complexity seen on ThreeI Atlast, and that mismatch pushed Atlast firmly out of the primitive category. In report after report, the conclusion was the same. ThreeI Atlast bore the signature of a body that had lived a geological life before being exiled to interstellar space, and the chemical fingerprints scattered across Atlast's surface were the last fragile record of that lost history. High-resolution shape models turned the point of light called ThreeI Atlast into a rugged world. Across the rendered surface, Atlast showed bright, relatively smooth expanses, lying beside dark terrains pitted with deep impact scars. In some regions, the limb of ThreeI Atlast cut across basins tens of kilometers wide. Steep-walled craters overlapped one another on Atlast, their rims softened in places as though the landscape had been reworked more than once. Spectra tied to those zones revealed crystalline ice glinting on the face of ThreeI Atlast. That form of ice does not simply condense and stay pristine. It requires heating, cooling, and time, a thermal history that Atlas could not deny. Researchers proposed that parts of ThreeI Atlast had experienced repeated cycles of warming and refreezing. In some of their models, Atlast once harboured buried layers, where temperatures rose high enough for pockets of liquid water to exist however briefly. If that picture was right, ThreeI Atlast had not always been a frozen husk drifting alone. Atlast might once have circled a distant star inside a complex system, endured impact tides and internal heat, and only later been stripped down and cast outward, with its record of ancient water locked into fractured plains and shattered basins. In discussions that spanned Observatories 3, Atlast acquired a new label. Rather than a comet or an anonymous fragment, Atlast was increasingly described as a planetary fossil, a shard of a broken world wandering between stars. The term that stuck was wandering relic, and ThreeI Atlast became the archetype. Atlast embodied the idea that galaxies might be filled with stripped dwarf planet cores ejected and left adrift for billions of years. Each such body would carry a unique chemical and geological record, and ThreeI Atlast was the first close enough to study in detail. By reading the scars and spectra of Atlas, scientists hoped to reconstruct not just a single history, but the broader story of how violent planetary systems can be. In that sense, ThreeI Atlast became more than a curiosity brushing past the solar system. Atlast was a messenger from destroyed architectures, proof that worlds can be shattered, recycled, and sent outward into the dark. As the community updated catalogues, Atlast stood at the top of a new class. Future surveys would search the sky for more objects like Atlast, but this first wandering fossil would remain the template for all that followed. As more tracking data accumulated, the faint, precise deflection of ThreeI Atlast's path became a kind of weighing scale. The way Atlast responded to gravity told dynamicists that they were dealing with far more mass than its brightness implied. When teams folded in all the perturbations, ThreeI Atlast emerged as both enormous and unusually dense. The numbers refused to let Atlast remain a fluffy aggregate. Atlast behaved like a single coherent slab of deep material. Brightness models had once suggested a modest porous object, but the dynamical fits painted ThreeI Atlast as a giant shard. In some reconstructions, Atlast looked like a broken piece of a much larger planetary body, carved from something closer to a giant's core. To understand how ThreeI Atlast could have been launched into interstellar space simulators, rewound time inside hypothetical home systems. They sent Atlast analogues skimming past swollen gas giants, hoping that a single close pass could sling Atlast outward for good. Most runs showed the same limitation around ThreeI Atlast. Even violent flybys of massive planets struggled to give Atlast enough energy to escape the parent star entirely. Attention turned to more crowded, unstable environments, where ThreeI Atlast might once have orbited. In those models, Atlast circled within a binary or multiple star system where overlapping gravitational tides twisted orbits into knots. When a heavy body in such a system was torn apart, fragments like ThreeI Atlast could be flung away on chaotic trajectories. A close three-body interaction could squeeze Atlast into a tight slingshot, shredding the original orbit and hurling Atlast into the galactic field. That picture left ThreeI Atlast as the survivor of a violent restructuring, a remnant from a place where entire worlds were rearranged or destroyed. Every precise astrometric update of Atlast's motion was not just a navigation aid, but a faint echo of the catastrophe that had first cast Atlast out into interstellar space. As ThreeI Atlast fell inward toward the sun, the quiet surface began to shed a new kind of veil. Under the growing light, Atlast sprouted faint jets invisible to the eye, but bright in infrared. Spectrometers on Webb split those plumes from ThreeI Atlast into their constituent colours. Instead of the simple fingerprints of water ice and carbon monoxide, Atlas showed a far richer chemistry. In the spectra, ThreeI Atlast carried broad features from polycyclic aromatic hydrocarbons, the pairs that haunt star-forming regions. Alongside them, Atlas displayed lines from nitrile's nitrogen-bearing molecules that sit a step away from amino acid backbones. On paper, the jets from ThreeI Atlast looked like exhaust from a laboratory experiment in prebiotic chemistry. The mixture around Atlast matched what researchers had once tried to synthesize in controlled flasks and discharge tubes. Astrobiologists began to circle the data from ThreeI Atlast, marking the same transitions again and again. They knew that PAEs and nitriles are not life, but they are often the scaffolding from which life's molecules grow. If fragments like ThreeI Atlast drift through young systems, they argued then Atlast could act as a delivery vessel. Every close passage of Atlast past a warm star would drive off jets laced with complex organics into circumstellar space. In that view, ThreeI Atlast was not just a victim of past violence. Atlas became a potential seed carrier, scattering chemical possibilities into disks where new planets were still assembling. Skeptics pointed out that complex molecules can form without help from bodies like ThreeI Atlast. They reminded everyone that PAEs and nitriles appear in many environments where no obvious Atlast analogue is present. Even they, however, conceded that the concentration seen on ThreeI Atlast was striking. Few known objects combined scale interstellar travel and such a rich organic inventory the way Atlast did. So the discussion settled into a careful conditional tense around ThreeI Atlast. If panspermia plays any role at all, then bodies resembling Atlast are among its most efficient couriers, and each new jet from Atlast looked a little less like waste and a little more like potential written into space. For months, the mass estimates and light curves for ThreeI Atlast had advanced together without serious disagreement. The orbit of ThreeI Atlast implied heft, while the faint reflection still suggested a porous, mostly empty world. Once the detailed dynamics were folded in that quiet compromise snapped. The way gravity tugged on ThreeI Atlast, and the way Atlast replied, demanded a dense, consolidated body. Brightness models could be retuned, but the momentum of ThreeI Atlast could not. The same equations that weigh moons and asteroids now weighed Atlast and pointed toward planetary core territory, not fragile snowballs. That alone would have been unsettling if ThreeI Atlast had behaved like a dead relic. Instead, the logs still showed Atlast performing a 4.3 km per second velocity change in 14 bounded minutes. Teams laid the two facts beside one another and stared at the contradiction of ThreeI Atlast. Atlast was huge and heavy, yet Atlast had moved as though some internal system had simply chosen to push. To reconcile the data, some researchers pictured ThreeI Atlast as a captured mountain. In that view, an external intelligence had burrowed into Atlast and installed machinery, turning a natural shard into a mobile stronghold. Others tried to keep ThreeI Atlast on the natural side of the ledger. They asked whether complex bodies like Atlast might hide unknown feedbacks or deep phase transitions that could mimic propulsion. Each attempt to rescue familiar chemistry and mechanics left a residue of unease around ThreeI Atlast. Either Atlast had been deliberately engineered into a vessel, or Atlast was teaching that the line between rock and engine is far thinner than anyone expected. In both readings, Atlast stopped being a passive object and became an active participant in the unfolding story of the solar system. For a long time, interstellar travel lived mostly in equations and fiction. ThreeI Atlast turned that abstraction into a visible track across the sky. By reshaping its own orbit, Atlas proved that crossing between stars is not merely a thought experiment. The controlled burn and sharp course correction from Atlast were demonstrations, not hypotheticals. Autonomous operation over incomprehensible timescales had also seemed like a distant engineering dream. Yet ThreeI Atlast arrived in the solar system still functioning, still adjusting, still talking. Whatever mind once launched, ThreeI Atlast had planned for durability beyond any human mission. Atlast embodied the idea of a system that can run, adapt, and navigate for eons. The combination of propulsion signaling and coordination around ThreeI Atlast forced an uncomfortable admission. Somewhere at some time, a civilization existed that could build something like Atlast. By comparison, even the most ambitious probes from Earth looked brief and fragile beside ThreeI Atlast. Humanity's proudest vehicles felt like first attempts scratched into wet sand, while Atlast crossed gulfs between stars. In that light, ThreeI Atlast became a measuring stick for the species watching it. Atlast confirmed both that advanced technology is possible and that on the cosmic scale humanity is still very young. Some readers chose to see ThreeI Atlast as a messenger, not a threat. In that gentle frame, Atlast adjusted its course and lit up the spectrum simply to announce presence and capability. If the primer and data stream were an invitation, then ThreeI Atlast might be offering a controlled first contact. Atlast would be demonstrating what it can do while carefully avoiding any direct harm. Others stared at the same evidence and found a colder script in ThreeI Atlast. In their eyes, Atlast was running a reconnaissance profile mapping a target system, with the calm of a surveyor before construction or conquest. From that perspective, the controlled burn of ThreeI Atlast looked like proof of force. Atlast would be quietly stating that distance, gravity and time are no real obstacles. Patricia Foster tried to hold both narratives at once whenever she spoke about ThreeI Atlast. Foster argued that Atlast should be treated as neither an omen of friendship nor a guaranteed threat, but as a fact demanding honesty. Her recommendation was simple in words and difficult in practice wherever ThreeI Atlast was discussed. Humanity should be transparent with itself and with whatever might be listening, while remaining cautious about how much authority is ceded to Atlast. In strategy sessions, Foster reminded colleagues that no realistic deterrent exists against ThreeI Atlast. The only leverage left was how clearly, calmly and collectively the species chose to respond to Atlast. That framing turned ThreeI Atlast into a mirror for human decision-making. Rather than fantasizing about stopping Atlast, the real question became what stance humanity would adopt in a universe where something like Atlast already moves freely. Behind closed doors, the debate over how to talk about ThreeI Atlast dragged on for weeks. Some argued that keeping Atlast classified would prevent panic, others warned that secrecy would poison future decisions. With each briefing on the propulsion event and technosignatures from ThreeI Atlast, the sense grew that Atlast was too large and too close to remain hidden. Eventually, the highest councils agreed on a pivot: the world would hear about ThreeI Atlast openly and in full. The United Nations called a joint press conference bringing together agency heads and scientific leads who had worked on Atlast. Draft statements walked carefully through the evidence, showing where conclusions about ThreeI Atlast were firm and where they remained open questions. One section described Atlast as evidence of non-human technology, while refusing to assign motives or myths to whatever mind had built it. For many, the hardest line to approve was the admission that humanity had no means to control or deter ThreeI Atlast. Saying that aloud felt like stepping onto a stage unarmoured, yet leaving it unsaid felt dishonest in the shadow of Atlast. When the day came, the blue UN backdrop framed a new kind of message, and every major screen carried the name of ThreeI Atlast. The countdown to ThreeI Atlast's approach was quietly marked on calendars around the world. Each new orbit solution for Atlast narrowed the uncertainty, drawing a thin circle around the 28th of December. Observatories scheduled their final campaigns, assigning precious dark hours to follow ThreeI Atlast night after night. Engineers rehearsed contingency plans not to stop Atlast but to keep instruments awake when Atlast came closest. In public, the headlines called ThreeI Atlast a once-in-history encounter. Privately, many admitted that Atlast felt less like a passing guest and more like a hinge in time. For optimists, ThreeI Atlast represented a doorway into a wider community of minds. If any response ever came back along the channels, Atlast had opened, the answer would begin lifting humanity out of its long solitude. For others, ThreeI Atlast marked the end of any illusion of cosmic control. Whether benign or indifferent, Atlast proved that greater powers had already crossed the distances humans only dream about. Either way, the presence of ThreeI Atlast rewrote the baseline assumptions of every long-term plan. No future history on Earth could honestly ignore the day when Atlast threaded the inner system and kept going. In the end, ThreeI Atlast remained outside anyone's command, a fixed point moving through shared sky. What would define the era of Atlast was not the trajectory of the visitor, but the choices made by the species watching that silent vessel drift past their small bright world.